Hello Matrix and welcome again. Today we are looking at functions and we're looking at parabolas and specifically the intercept form. Now last time we did the standard form of a parabola, which is ax squared plus bx plus c, which most of you are used to. We need to know the different types of forms. So today we're doing the X Intercept form, and then tomorrow or the next lesson we're going to be doing the turning point form. So let's look at what the X-intercept form means. So you're given the function, so this is the standard form in its X-intercept form, where x1 and x2 are our two X-intercepts. And if we're given another point on the graph, we could then substitute that in for y and x, which are the purple values, and we could figure out what a is. And then if we multiply that out again, we can get it into the standard form if we needed to. Okay, so this is the X-intercept form. It's when you're given the X-intercepts and a point on the graph. So if you see the two X-intercepts and the point on the graph, you need to know your standard form. So this thing is important. You need to know this general form. Now, we look at this question, question 6, because you really want to be doing past papers, because if you look at just this lesson and we don't do a past paper, you don't get used to the types of questions that they ask. And so when you get given a question, suddenly you're like, I don't know what's going on. And so you need to be able to apply what you learned to a past paper question. So as many past paper questions as you can do, the better. So let's look at question 6, which is from a 2015 supplementary paper. And we are given f of x is ax plus bx plus c. So they don't tell you the values, but what they do give you is the x-intercepts. And they also give you d, which is a point on the graph. And then they tell you this g of x here is a tangent to the graph. So we're given our roots and we're given our 1 point on the graph. And so we can use this standard form. So let's look at what the first question says. It says, for which values of x is f of x less than 0? So where is it f of x below the graph? So we can see that it's below the graph. I haven't drawn that very well. All over here. And then on either side of that, it's above the graph. So we know that x over here is -3. So we can just say then for question 6.1 that it's between -3 and 2. So we know that x is greater than and equal to and greater than and equal to. So that's 6.1. Let me just make a smaller pen and change this to white. Okay, so 6.2 says determine A, B, and C. So they want A, B, and C. Well, we now know that we can use the f of x equals ax minus x1, x2 in order to solve. So we know that f of x equals ax minus x1. So this is the intercept form, right? And now you can sub in values. Well, f of x, we've got a point. We can sub in d, right? And x1 and x2. So let's do those. So let's do those in blue. So that was this and this, right? So we know that x1 is -3 and x2 is 2. So we could put those in there. We also know that our f of x is a y value, which would be -8. So that was in purple. And our x value was 1, and so we could put in 1 for all our x for those two x values. And we could then figure out what A is. Okay, so now we've subbed in our x points and our x's and our, we subbed in our x-intercepts and we subbed in our point D. And now we can simply just solve. So solve for A. So -8 equals. So 1 minus -3 is +3. So it's 4 and then 1 minus 2 is minus 1. So then A is going to be 4 multiplied by minus 1 is 4 multiplied by minus 2. It's going to be minus 4, yeah. So A negative 4. Now we divide through by negative 4. So we get A is equal to 2, which makes sense because it's a happy face graph. So A must be positive. Right, so 6.2. Now we can put A back into this equation here. We can put A back in with our roots. So Y is equal to, now A we now know is 2, X minus, and then we put in the minus 3, which became plus 3, and then X minus 2. And now we multiply this out to get the standard form of the equation. So this is just the usual parabola, but it's in a different form. And we want to get it into the standard form. So this becomes 2, and then x times x is x squared, and then plus 3x minus 2x is minus x, so it becomes minus 2x. Sorry, plus 3x minus 2x will be plus x, so it'll be plus 2x. And then 3 times minus 2 is minus 6 times 2 is minus 12. Okay, so that is our standard form. So now we know that A equals 2, B equals 2, C equals minus 12. Now they want the turning points of the parabola. So to find the turning point, we can simply use our turning point formula, which is, you need to remember this, the x value of the turning point, I'm just going to write this in, although you don't need to in your exam, is equal to negative b over 2a. So just remember that. Okay, so x is equal to negative 2, because that's b, over 2 times 2, and that's going to be negative 1/2. Well, that makes sense, because it's going to be roughly there. And then the y value, you just simply substitute negative 1/2 into the original. And so y is equal to 2 times negative 1/2 squared plus 2 times negative 1/2 minus 12. So this becomes a quarter. 2 times a quarter is 1/2. And then this becomes 2 times negative 1/2, which is 1. So this is, let me just write this in. This is minus 1 and this is minus. You could just put this on your calculator. And then, but don't be lazy. Although actually use your calculator in an exam, because you don't want to make a silly mistake. So this would be negative 12.5, which is negative 25 over 2. And so your turning point is going to be then, the y value is negative 25 over 2, and the x value is negative 1/2. So it's negative 1/2 and minus 25 over 2. Turning point. Now they want you to write down the equation of the axis of symmetry of h of x minus 7 plus 2. Okay, well, let's look at what the axis of symmetry is. So I'm going to do this in, what have we missed? We haven't done green. Okay, so here's the axis of symmetry of the current f of x. And we know that this value is minus 1/2, this turning point, and negative 25 over 2. Okay, so what we can then do is we can say, well, what does this h of x do? So what does it do? So h of x is basically f of x, but changed somewhat. in that they move it up by 2, because this plus 2 would then say that it's this, but we add 2 to it. So when we add 2, this changes the y value and it brings it up by 2. So then this value here, let me do it in orange. So this here plus 2 goes up by 2. And minus x minus 7, so x minus 7, that shifts it left and right. So remember, this plus 2 shifts the y up and down, and the minus 7, so minus shifts it forward because it's counterintuitive, and then plus shifts it backwards. So minus 7 is shifting this negative a half. We'll do that. So this was our plus 2 in orange, and then our red, we'll say the negative a half. That's this minus 7, and so it shifts it forward by 7. So it increases by 7. So we can now say the equation of the axis of symmetry, well, we at least can get the point of the line. Well, we don't really need to know the y value, because the axis of symmetry is still going to be, it's going to be moved to here. But whether it's moved up or down, the axis of symmetry is still, so even if I move this pink graph, even if I moved it up to here, do you see that the axis of symmetry is still x equals negative a half? So all we worried about is what happens to the x. Well, 6.4 is the question. So we're basically saying it's moved forward. So it goes from negative a half forward to 6.5. So the answer is x equals 13/2. 6.5, they want the gradient of g of x. Well, the gradient of g of x means the slope at this point. Well, we know the slope of this is calculus, we know the slope of a parabola is the derivative. So all we need to do is we need to get f dash of x. And this I will go through in calculus if you don't understand. But f dash of x is going to be that 2 times 2 is 4x, and then if it's an x here, you just put the derivative is going to be whatever stands in front of the x, which is plus 2. So now this is the tells you the gradient of this pink graph f of x at any point. And if I was to substitute in the x value of the point, it would tell me the gradient at that point. Well, I know the x value is 1. So then I know that it's going to be, so I can say f dash of 1. So what is the gradient where x is 1? Is going to be 4 times 1 plus 2, which is equal to 6. So now I know that the gradient is 6, and that's all they've asked for. So we can just say m of g is equal to 6. Okay, so that's a question with using where you were given your 2 x-intercepts and a point on the graph, and from there we just were able to do most of the question, and then the last few questions is just about understanding how does the graph shift when I change the value that's next to the x, and how does it shift when I move the y up and down, and then just basic concepts, which we're going to keep doing, and when we do more past papers, you'll see the type of questions that come up in these exams. So hopefully that helped. Next time we're going to be doing the turning point form of the parabola. And so now if we know these 3 forms of the parabola, we can do most of the functions question. And then it's just understanding the nuances of what they can ask you. So if this helped, please find your like, subscribe button on the screen below and click that and share it with your friends and all that good stuff. And yeah, keep supporting me, and I will keep uploading videos and helping you guys get a great matric. So yeah, look forward to seeing you in the next lesson. Have a great day.